The more you struggle, the more you figure it out. Jeff, want this closer? And you continue to struggle, and you continue to learn new things throughout the more you work with it. I had to figure out doing a whole new process yesterday, so it's a good skill to be able to continue to solve problems. Okay. So I can help you with your, if anybody's still struggling with labs, probably at the end of today's lab, we can work on that a little bit more. And maybe you'll find some new tools today to make that process easier, which you'll see now. So we're going to talk today about geoprocessing, starting more into some spatial analysis components of GIS, not just for map making, but different kinds of things we can do with it. And really, spatial analysis is the reason why we have GIS. It's the best parts of it are what we can do when we start working with our data spatially. Let's see if I've got. Melanie, I feel bad that I'm never talking to you here. Not even sure if are you listening, Melanie? Okay. So we call it geoprocessing. And essentially all of the different GIS operations that we're going to use to manipulate our data can fall under this geoprocessing title. Typically, we're going to take an input data set, usually multiple data sets, manipulate them in various ways that we'll go through some of them today, and then produce an output data set. So just a very basic diagram of what that looks like. We use different geoprocessing tools to transform our data into a new data set on the other side. Like I said, it's typical that you'll use a lot of different data sets. It's that combination of data that we really like, that we use a lot in GIS. Sometimes it's just extracting some values from one data set as well. And oftentimes we have to go through a process of pre-processing or data prep to get things ready to do our geoprocessing. So as I said, sometimes you're starting with just a single data layer, you're extracting values, you may just do some transformations to that and pull out different spatial data layers from it. Or you may start with multiple spatial data layers and do different types of combinations to come out with a single data layer. And the other thing is that we can also end up with tabular outputs. That still counts under geoprocessing. As we build multiple steps together, you can build more and more complicated models and end up with whatever your final output that you need is. So it can be multi-step, it can have different inputs, it can have different outputs. It all falls under geoprocessing. So today we're just going to start with some of our geoprocessing tools. We'll go through these each in turn. In your ARC toolbox, there's different ways to access all of these. Under your geoprocessing menu, some of the most frequently used ones are listed right there for you. Inside of your ARC toolbox are a huge number of other ones, all in different subfolders, just to show you that. And as always, as I've told you guys, this search window is one of your best friends when you're trying to figure out where the tool you need is. Click on your search window and it will take you right there. Okay, so overlay. Overlay is kind of a head title for a bunch of different geoprocessing tools that we use. And whenever we are overlaying data, we're just taking two different layers and overlaying them, putting one on top of another, essentially. If you guys remember, that was kind of one of the first things that started the development of GIS, was trying to ask questions about suitability and needing to overlay different features in a landscape, putting them on top of each other to answer questions about suitability. Typically, when we do an overlay, we're forcing the features to split where they overlap one another, and we're creating new features. Depending upon what function we're using, either the attributes associated with our spatial polygons can be retained, or they can be not retained. So another sort of visual expression of that, where we have two different spatial data layers, and when we combine them together in some type of overlay operation, we end up with a new one. And you'll see that in this one, it's showing you how you are combining your attribute layers. Overlay operations can be done in both raster and vector data, and they look very different in each one of them. For a lot of reasons, raster data overlay operations are kind of some of the basic geoprocessing you do in raster. You do a lot of different overlays. Because you're working in a grid, when you're working in rasters, a lot of those overlays are much simpler than when you're working in shapefiles, where you've got different polygons of all different sizes or lines. So it's much easier to kind of think through how those overlay processes work in raster. But because we're in our vector section, we're not going to talk too much about that today. But know that it does apply to both. So there are two types of overlay operations. They're either extractions, where we're trying to get something out of a shapefile of our data, or there's overlaying, where we're trying to combine them. So we're going to talk about clip and erase. I put a box around erase here because we don't have the right license to do an erase function in ARC, which always drives me crazy, because it really would be convenient frequently, but you have to have an ARC editor license, which most people don't have. But we'll talk about it anyway, as well as these different overlay operations, intersection and union, where we're combining our features and our tables. Have you guys have you ever heard about clipping? We'll talk about clipping your shapefiles all the time. That's one of the main extraction tools that we have. Again, we're including erase here, but you can think about all of these functions as sort of a cookie cutter, where you take, you've got your data, you've got your vector file, and you need to take out just one portion of it. So if you need to pull out something from, say, from a shapefile, you can use the clip function to isolate that. And the inverse of that is erase, where you're, instead of clipping it out, you're taking it out of that first layer. So instead of extracting the feature, you're removing that area. So what these functions do is they help you isolate particular areas of interest. It sounds very similar to your queries, where you were doing your, say, spatial queries with your attribute tables. But when you use the clip function, you're able to cut a whole feature into pieces, which you guys know why you would want to do that now, right? You want to cut those rivers off on the river basin line. You don't want the entire feature to be retained. And with queries, you have to take the whole feature. So what that looks like here is when you're working with clip, you have your input map, you have a feature, your clip feature, and your output is just going to be this first input map, but just within that boundary of your clip feature. The opposite of this here is erase, where you want your input map, but you don't want whatever this feature is in the middle to be included, so you would be able to remove it, theoretically, if you had an ARC info license. I think I understand what you're saying. Hold on a second. So clip, like make your clip feature this thing. I know there's a reason why that doesn't work. I guess maybe if it was really simple, then it could work. It's frustrating. Is really what it is. They're so yeah. Why can you not do that? I don't know. I don't know why. I'm not allowed to call it the evil empire, right? Okay. The clip toolbox. The clip tool is inside the toolbox under your extraction features. And this is what the dialog box looks like. We'll work with this a little bit later in lab, so just so you see it. And again, when you're working with clip, you have to have two features. You have your input layer, so that is what you want the data out of. So if you want the roads here, your input layer is the road map, and then you have your clip feature. So that's like the shape you want extracted, or your cookie cutter, if you think about it that way. And so clip is only going to keep the input features from whatever this shape is. It's not going to keep any of the attribute data from your cookie cutter. It's only going to keep the information from your input layer. With clipping, your cookie cutter shape, that layer always has to be a polygon. So you can't use a roads layer or a point layer to clip features out. It has to be a polygon layer. But your input layers can be anything. They can be points, lines, or polygons. So you can extract information on roads, you can extract information on point data or land use data, whatever you need to extract. So just showing that again, the different geometry types that you can use for clipping. This feature, your cookie cutter, always has to be a polygon, but your inputs can be anything, either polygons, lines, or points. In your output, only the attributes from your input features are going to be preserved. And as you'll notice, also, it's going to keep the same geometry as your input feature. So if you're clipping a polygon file, you're going to end up with polygons. If you're clipping a line file, you're going to end up with lines. This is what the erase tool theoretically looks like. And again, erase, which we don't have, this is what it would look like if you had it. And again, your output coverage is going to be the same as your input coverage. So just a comparison again of what it looks like if you're doing clip versus select by location. Here you've got a road map, and when you use clip, those edges of your roads aren't included. But if you're doing select by location, are those really hard to see? You can see they've got these little dangles that go over. We haven't talked about geocoding, but when you use geocoding, you actually want those dangles. So that would be when you would keep those. Geocoding is when you fill in address information from points. So we'll do an exercise about that because it's a good tool for you guys to know. Okay, so if you want to keep the attributes, instead of clip or erase where you're only keeping the attributes of one of those input data sets, if you want to combine data sets together, that's when you do a different kind of an overlay operation. So here we're looking at a slope map and a soils map, and you need to know information from both of them. So what we're going to do is we're going to superimpose them. We're going to create new polygons. We're going to split those features, but all of the information from each one of our inputs is going to be retained. So our final output here is going to have new polygons, but the attributes of both soil and slope are going to be in that new attribute table for us. It's a one-to-one relationship, so when one polygon matches another polygon, you're going to end up with your output from both of those. You can't combine, the polygons have to cut each other. You can't have multiple, like like overlapping areas included from beyond where those two meet. Okay. So again, if we wanted to know the relationship between, say, roads and land use, we could also have done that with a query by location. We could have asked what's the length of the road inside all of these polygons, right? By doing that intersect operation that you guys got to do in your lab many, many times. If we were going to do that and do a query by location, as you guys know very well, what you would have ended up with would be the entire stretch of that road because it would be the intersection. In contrast, when we do an overlay, only the portions that intersect are going to be included. And the other thing that's going to happen is that our road's going to be split up. Wherever that line feature is going to overlap a polygon, it's going to become a new feature on its own. It's going to get split. So then we're able to remove sections that we're not interested in. So here we're looking at the different types of overlays we can do. We can either use a union function, where the total area from both of our inputs is going to be retained in our output layer, or we can do an intersection operation, where only those areas where we're going to have an overlay are going to be combined. So here, if we have a parcel and an oil spill, our union result is going to be everything, the entire universe. Our intersection result is only going to be those areas where they overlap exactly. So intersection's going to combine our features and keep less. It's going to keep only what's common to both here in intersect. And it's going to build a new feature class with only those shared features and the shared attributes. Versus union, where you're going to get everything, and you're still going to get all of the attributes of each of them. So you're going to be able to retain the attributes from both of your layers, but it just depends upon if you're only interested in where they intersect, where they are exactly on top of each other, or if you're interested in all of each universe, each data set. With union, you're overlaying two polygons, and your output is going to be the combined spatial data as well as the attribute data of both of your input layers, independent of whether or not they overlap. So here's an example where you've got neighborhoods and zip codes that you want to combine. Those are the zip code lines. So our union tool is, again, in our analysis tool under the overlay operators. We might want to do this because we want a more specific description of our neighborhoods, about the characteristics of our neighborhoods. So we're trying to isolate something, for example. So it's showing that here you've created a union. So you have both of the data sets included. You've got the zip code data as well as the neighborhood data. This is showing the attributes, where you've got different attribute tables to start with. So here's our zip code, here's our neighborhood data. Your union result, sorry guys, my phone is doing something and it's dying on me, and I need to figure out why it's doing that. Pardon me. Phones ever have a mind of their own? Apparently trying to upload photos for no reason. Ah. Okay, let's see if that works. Okay, sorry about that. As you can imagine, I need to be in phone contact most of the time. Okay, so with union, our results are we're going to have a new polygon that's going to have the combined data. So this is just showing you where you've got here your zip codes, as well as your neighborhood information associated with it. So again, just what that looks like, where with union, you've got your input layers, and everything is going to be retained in your output. With intersect, you're just looking at the intersection of your input features. So only the portions that overlap are going to be retained in your output layer. With intersect, your inputs can have different geometries. So an example of where this might be an important tool is if you wanted to know, or a city manager needed to know, what buildings were in a flood zone, and needed not only to isolate that information about the buildings, but also needed to keep the attribute data about those buildings included. Here we see where the intersect is under our overlay little lovely toolbox. And the result here is showing, again, just those buildings that are in the flood zone. So just what's being, it's not the full universe, it's just where those two layers are actually intersecting one another. And you can see that it also has all of the information associated from both of the data sets. So you've got information about the building, as well as from the flood zone. I can't see which one. I guess it's this one, is the flood zone information as well. Just showing again what that looks like. A comparison. You can see that with intersect, your input layers can be different, and what your output is going to be just the shared areas. Okay. So when we're going to overlay features, if we want to keep all of the data, all of the information from both of those layers, we'll use union. And if we want to isolate that and reduce it and look only at where the layers are overlapping one another, we're going to use intersection. It's going to combine our attribute tables, which is great. We want that. And our result is going to be both a new spatial data set, and that spatial data set is going to have new attribute information from both of our layers. Okay? So just examples of what that's going to look like, where we might be applying this. Andrew? It's going to, remember, create new features wherever those roads are going to intersect with the counties. It's going to be a new feature, and then the attributes of both will be combined. So every separate road would then have county data associated with it. Not if they overlay each other spatially. Yeah, you can imagine your projection has to be the same and have to make sure things line up. So you use this a lot to combine your data layers. This is just showing you if you needed to know, say, where what parcels were being impacted by an oil spill, depending upon if you were interested in everything that was in vicinity, maybe you would want to do a union to include it. This is your polygon showing you the new output after union, and see how you have new attribute data that's going to combine both of those. Okay. See, I just knew your question was coming. And see how in some of them, if you don't have, if there's not a direct overlay, you have empty spaces in your attribute table. Here again versus the intersection where you're just going to be isolating that one feature, that one area where there is a direct shared area between those two layers. And then your attributes will only contain information about that. So the other thing that you might say, well, couldn't we just have done a clip to get that data out if we're only interested in that particular area? But what you see is that the attribute table, if you're going to do a clip, is not going to be combined. It's only going to be the attribute table from whatever feature it was that you were taking the data from. So if you need to combine the attributes, you have to use those overlay functions, not extraction functions. And that's just what I said. So if you need to keep the attributes, you use intersect. You don't use intersect or union. You don't use clip. So frequently when we're using these, it's when we're trying to identify where different conditions are being met. So if we have a particular question, say we're trying to figure out where the best habitat for a species might be, and we need to know if there are particular hazards in that area, or if area is already being preserved for it. We can ask all sorts of different questions. We can use these different functions. So when we use a union for this example of potential habitat and risk, it's going to keep all of the input features. So we're going to get both the full range of the habitat and the full range of the risk. If we're going to use intersect, it's only going to be where they're going to be combined. So you can think about that as an and operator. Remember with your Boolean, whenever you're creating those different Boolean expressions, and is much more restrictive than or. Or is going to be combining both. So union is really like an and an or, where intersect is just the and. So here's that image again where you need to know about different types of soil or geology and slope. When you're doing the union, you're going to be able to combine all of those, and each one of these new little dudes here is going to be a polygon, and you're going to get information about both of those attributes, so you can isolate areas that would maybe be of particular risk based upon those two attribute tables. Union. And then we have in our new polygon both our slope class and our geology class. Here's a different example where you needed to know just residential areas that are at risk of radon. So you're taking your residential polygon areas, you're taking your formation that has a higher potential for radon, and you're doing an intersection because you're really focused on where are those two data sets, those two layers going to be combined. That's your area of both. This is showing why you wouldn't want to use union. So why wouldn't you want to use union here? What's union showing us? What was our question? Okay, you've got residential data, and you've got this geologic formation that has a higher risk of radon. And so you're looking at where are you concerned? Where would you isolate what's your target area to think about maybe doing more testing for radon? Yeah, union's going to give you everything, and intersection's going to give you... Yes, where both of your criteria are going to be met. Okay, so it's important to think about what your output's going to be, and that's going to determine what sort of operation you're going to do. Okay, so I mentioned that you can do these in both, you can do overlay operations both in vector and raster. So here's an example of a raster overlay. Here you've got a different elevation map, and here's an agricultural map. And what you've done here is you've turned them into maps that have 0 and 1 values. Do you guys know what a map that has 0 and 1 values would be called? Yeah, really close. That's also another way to call it. We call them Boolean maps, where you just have a 0 and 1 value. You're isolating just one criteria, and you're making a map where it's like a yes or a no. So no is 0 and yes is 1. And you've done that for both of your criteria. Frequently in raster operations, that's what you have to do. You have to isolate one criteria at a time if you're trying to only look at a yes or no answer, yes or no question. And then you're combining your data here. What do you guys think in terms of an overlay operation? What does this look like? And yeah. Yeah, so there's Boolean. It's and, or it's a multiplication property if you were doing a raster combination. Okay, so one thing you can end up with when you do these overlays are things that we call slivers. Just these itty-bitty, teeny-tiny, really annoying polygons that you end up with. So when you do an overlay and you had, say, 6 and 10 polygons from your original data sets, you can end up with, 500 in the end, depending upon how they lay on top of each other. And that can be a real headache when you're trying to do other processing steps or just trying to work with your data. Frequently, this happens because you're working with data layers that aren't intended to line up, or because you have different problems with your data sets to begin with, like your county data is coming from 2 different sources and those boundaries aren't going to line up exactly. So it can become quite a problem for you. And the way that we deal with it is either you can go in and you can manually remove them and edit them, which would take a lot of time if there were a lot of them, or you can specify when you do your processing in your processing environment that you want to reduce the slivers depending upon the different tolerances you set. We'll talk about that more in editing. Okay. So to summarize what we've kind of gone through today in a lovely visual diagram here, you can see we've talked about clipping, where you're just removing a section of your input data. And remember, with clipping, only the attributes from your input data layers are going to be retained. And the same theoretically would be the same with erase if we could use it. But when you want to combine your attributes, you're either using intersection or union. Intersection only where those two are overlaying one another, and union is the entire universe of both. Okay. As I've mentioned, they have different allowed inputs. So for clip and erase, your inputs can be anything, point, line, or polygon, but you can only clip with a polygon. And your output will always have the same geometry as your input. So if you're clipping points, you'll end up with points. When you're doing a union, you have only polygons that you can combine together. But when you're using intersection, they can be different. They can be points, lines, or polygons. Again, your output geometries are always going to match your input geometries. With clip. In an intersection, you can choose what kind of geometry you want as your output. Another display without erase, showing you guys what the outputs of all of these are going to look like. Okay. Okay, so another type of geoprocessing tool that we'll use is dissolve. That's where you're going through and you're dissolving the boundaries. You're creating a larger polygon from smaller polygons. An example here is like if we wanted to look at sub-regions in the U.S. instead of every state in the U.S., we could dissolve our states into sub-regions. As you can see in our attribute table, we have a category called sub-region, so that's what we would be dissolving on. And what we do is we're creating a whole new layer based upon whatever it is that we want to group our data on. Usually when we're doing this, it's because we don't need all of these little polygons, or we're interested in increasing our analysis area for some reason, or we just want to get rid of those annoying lines between our polygons if they share the same value. And what happens is that the boundaries are dissolved away. That's why it's called dissolve. We always choose what the attribute is that we want to be dissolving on. So here is an example where we want to dissolve on the street name. So anything that's Main Street, we want to be included as a single line. Or if we're dissolving on our habitat class, so that all of one type of habitat are going to be dissolved. So we're dissolving on polygons. So here's that example where we want to look at regions. So we choose what the dissolve field is, and we have this common value that's shared between the polygons that we want to dissolve. Inside of the dialog box, when you are looking at dissolve, it gives you the choice here of what your dissolve field is. When you're going through and you're doing a dissolve function, you can do different attributes if you want, like to calculate statistics on your new subregions. You can do that inside of this dialog box. So it's asking you here what type of statistics you want to do. You're doing a summary of your population. So that's part of the operation right there. So here's what that end result is going to look like. You've got new features. All of the states within those subregions, the data in your new attribute table, so you can see that you've created these subregions. So there's only one polygon for each, and because you went through the summary in your dialog box, it's all included here. Okay. So again, what would be the difference? Why would you do dissolve instead of just summarize? Both, if you were going to summarize that based upon the subregion, you'd end up with all of the data, but the difference is that you wouldn't have the new feature layer if you wanted to do some sort of mapping with it. So you could get that data, get the numbers on the population through summarize, but you wouldn't get your spatial layer. Okay, so this is where dissolve is under the generalization category in your toolbox. This is showing again what that looks like. Then you can make a nice pretty map. And this is just a much clearer slide of what we just looked at. So you can see here what the dissolve field that you were working with was. Okay. Okay, so whenever you're going through the process of inputting multiple data layers, coming out with another data layer, you have to think about what the implications are for things like area and length. So typically, you're interested in those attributes, right? You want to know what the area is for. Here's a map of snail habitat. So you needed, you had like a stream layer, and you had a different polygon layer for vegetation types, and you combined the two of them. And now you need to do a calculation. If your input features, like your stream layer, had attributes that were measuring the length of your streams or the area of different habitat, then those aren't necessarily going to be updated when you overlay them. So you'll end up with these new attributes, but the the components of your attribute table that have the fields that have length of stream won't necessarily have the correct values updated. It will have the original values. Do you guys remember the problem with shapefiles versus layer files in a geodatabase is that your areas aren't automatically updated. So when you're working and you're combining different shapefiles, those areas, those lengths aren't going to be updated automatically. If you're working within a geodatabase, it will be, but most of the time you're not. Most of the time you're still working in shapefiles. So this is what if you have these attributes, these things are exactly what we're talking about. These are not going to be updated automatically. You guys remember this slide from before, some of the differences between shapefiles and geodatabases. Our geodatabases are these big containers that are going to hold all of our feature classes together. They have benefits of keeping everything, having topological relationships stored, so that all of the relationships between your features are going to have to stay the same, and it's also going to have this automatic tracking of lengths and areas. So it's one reason to consider working with geodatabases, so you don't have to go through that extra processing step of going back and calculating areas. It's just something that's important to keep in mind when you're doing geoprocessing. Okay. But the good news is that you can go back and you can fix the problem. So after you've done this this overlay and you have a new shapefile with just your snail habitat isolated because you were doing an intersection, you can go through and in your table go back and calculate your new area. We'll look at that firsthand, but you just go under the calculate geometry, and it gives you all sorts of options about what the units are that you want your area to be calculated in. Okay, so what we've gone through so far are these different functions: the extraction, mostly clip, the overlay, union, and intersection, and how we always have to think about area and length. And we talked about dissolve as well. So there's that slide again. So inside of our toolbox, yeah, Andrew. No, it's going to associate the entire attribute to each one of it. Yeah, so that's why something like area, it's going to, if you've got a polygon that's been cut in half and it had an area field associated with it, and it's in a shape file. If they were categorical, like if they weren't numbers, they would be whole. If they were areas or lengths, things like this, we could recalculate them. Does that answer your question? Okay. Okay. So toolbox, we've used it just a little bit so far, but it has hundreds of different things that we can do, lots and lots of different geoprocessing tools. We'll be using it today to get to more familiar with them. And we have an environment setting. Remember about the slivers, that's something that we can play around with those environment settings if we need to think about what our output features might look like, if we need to change some of those options. But even beyond that toolbox that has hundreds of different tools within ARC, there's also a lot of add-ons that you can find, depending upon what kind of work you're interested in. This is just showing where there's a landscape fragmentation geoprocessing tool that you might be interested in. you'll find that there are a lot of things that are either standalone geoprocessing tools or things that you can import into ArcGIS. So as you guys get more interested in different kinds of spatial analysis, you might be looking for different tools that maybe you don't have the license for in ArcGIS, or maybe they just don't have the capacity for it. So I encourage you to explore all that. Okay. So we're gonna look at some of this stuff in lab. So I don't want to be too redundant here, but we can look at what it looks like to find some of these. Apparently, I talk a lot faster than I think I'm going to talk. Do I talk fast, guys? No. Okay. So again, Arc Toolbox takes it a little while to load it up here when you first load it, and a lot of our geoprocessing tools are going to be in these subfolders. As I showed you in one of the slides, this geoprocessing tab up here has some of our most commonly used ones. So we talked about clip, we talked about intersect union, we talked about dissolve. We didn't talk about merge, but I'll show you what merge does today in lab. And then if you can't find something, say erase, that sounds fun. If you type it into that search toolbox, it gives you everything that could be related to that. So then you go here and you click on it, and it says you don't have the license necessary. So you hit OK, and you try to figure out another way that you're going to go through that operation. Have you guys been? You haven't been doing enough analysis yet to be using that search tool, but a lot of the other ones, again, even after working for a while on something, I don't tend to know, like I don't know where a clip is in this enormous collection of tools. Distance, local. So I'm stuck, but I know I can go to geoprocessing and find what I need. Okay, so I need to upload all of your data to go through these together. So you guys want to start working on that, or you want to take a break now and come back a little earlier for lab to start? Okay. Okay, great. Well, it's 12, so let's say, why don't you guys come back at, you want to come back at, it's 5 of 12. Come back at 12:15 to start? Is that cool? Awesome.